Welcome to QuickWits. This is the first in my series of small, tiny help files designed to get you through a single isolated problem when you've studied the lessons and still struggle. Good morning, my fine Earth-stronauts. There's a question about Alpha Centauri here. Now, I've corrected this number. I goofed and it's been sitting here for like 4 years. I had the distance for 1 light year. Alpha Centauri's 4. I don't care. The technique is important. So if you've already done the math with the wrong number, that's fine. If this is beyond the year 2020, you're already looking at the corrected version. The question is, what do we do with this number compared to Earth? Well, we already have a problem. This 4.37 times 10 to the 13 kilometers does not have a 10 to the 6 after it. That's the raw value. All right, I have not removed 6 zeros. So you've got 2 choices to compare it to Earth. Put the 6 zeros on Earth or remove them off of here. I think you would find it easier if you simply took the 6 zeros off so it would fit on this chart. So that would mean all you'd have to do here is change this number to 4.37 times 10 to the, take away 6 zeros, we're left with 7 kilometers. To put this in superscript, insert text, superscript. Now let's bring up the calculator. 4.37 to the exponent 7 divided by 150. And I get 291,000 astronomical units. And again, just truncate those zeros. Okay? Now, another nifty way of doing this, I will show next. Stay put, microphone. I still haven't totally rigged up my workspace here. There we go. Okay. Start learning to do some of these things by hand. 4.36 times 10 to the 7, I believe, was the number we're dealing with, times another million, but we took it off all the numbers. And we're going to compare it to Earth at 150. And I can already tell you the number is about 3 1/3. How do I know this? Well, to turn this to a base number, like this one is, right? 150 could be written as 1.5 times 10 to the 2. So we removed it. And I'm going to be dividing this number by that number. Well, what happens if I simply changed 4.36 to 436? Am I allowed to do that? Sure. Where did I get times 10 times 100? I needed 2 zeros to do that. Where did I get them from? Well, I got them off of this exponent. So I borrowed them and I'm left with 5. That's perfectly valid. If you took all 7 off, you would do this. 4.36. I'll write a whole bunch of spare zeros. And I go 1, 2, 3, 4, 5. 6. 7. So when I'm done, it'll be 4, 3, 6, 1, 2, 3, 4, 5. That's removing all of them. I just took away 2 here. Now I'm dividing two numbers. 436 divided by 150. Well, 150 and 150 and 150 adds up to 450. So this is 3. Okay, and 5 zeros still left on. 1, 2, 3, 4, 5. 300,000. by grade 11, you really want to be able to do that. You can deal with huge exponential numbers by simply converting the front end of the number here to something really reasonable that you can do, and then keeping the zeros on your own. So if I said to you, I want you to take 36 times 10 to the 18th, and I want you to divide it by 720. You might go, I can't do that in my head. You most certainly can. All you have to do is start borrowing zeros. So I could turn this to 360 times 10 to the 17th. And then you suddenly go, wait a minute, that's a half. It's almost like Kaladi planned it on purpose. And you go, yeah, 0.5 times 10 to the 16th. You might go, I don't like this. Then borrow another zero. 5 times 10 to the 15th. And what's 5 times 10 to the 15th? A million billion. Okay? Eventually, you'll get really good at this, but it has to be introduced to you at some point in time. So allow me to introduce yourself. Students, meet exponential notation. Exponential notation, meet students. Ah.